Hello students, in this session I am going to explain about the multivibrators. Very important and very interesting topic in the ICs, in the integrated circuits. It is a multivibrators, it is very important for your examination also, for your practicals also, right? In your practicals also you have to do on this IC 555 timers, right? That is a multivibrators. Multivibrators means what? Multi means many, correct. Is an electronic device. It is an electronic device that is to used implement in the vary of the simple two-state devices such as relaxation oscillators, timers, and the flip-flops. Here, an electronic device that produces the non-sinusoidal waveforms as its output is known as a multivibrators. And in this multivibrators, why we are call it as a multivibrators means it doesn't give the non-sinusoidal waveforms, right? It doesn't give the non-sinusoidal waveforms, right? That is the working of the multivibrators. The generated non-sinusoidal waveforms are basically square wave, sawtooth wave, rectangular wave, triangular wave, or a ramp wave. First of all, I am going to give that one basic. This generate the square wave, triangular wave, sawtooth wave, and a ramp wave. This is a ramp wave. This is the waveform of the what I have told that in that multivibrators. It doesn't forms the non-sinusoidal waveforms. It is the sine wave is not using here, right? There are the three types of multivibrators. In the various type of the network, it is basically categorized by the type of the coupling network that is employed in the circuit of the multivibrators. These are as follows. These are the three multivibrators. One is a astable, monostable, and bistable multivibrators. The multivibrators are using the IC number. That IC number is IC 555 timer. IC 555 timer. That number is given to the IC. For every ICs, they are giving in a different name. IC 555 timers are using in the multivibrators. There are the two types of the ICs like that, NE 555 or SE 555 timer. NE 555 timer and the SE 555 timer. These are the two applications of the IC 555 timers. They are using in the multivibrators. The features of IC 555 timer, we are going to see that one. Let us see that one. Features of IC 555 timer. There are two type of 555 timer based on its nomenclature, NE 555 timer and SE 555 timer. While NE 555 timer can be used in the temperature range from 0 to 70 degrees Celsius, the SE 555 timer can be used in the temperature range from the minus 55 degrees Celsius to 125 degrees Celsius and has a temperature stability of 0.005% per degree Celsius. It can be operated of different power supply ranges. That power supply range is around 5 to 18 volts. It can be used either in the pulse generator or a oscillator by operating it different modes. The name 555 comes from the fact it contains the 5 kilo ohms resistors in series. Why we can call it as a 555 timer? 5 kilo ohms, 3 resistors are connected in series. That is a voltage divider pattern in the series. That is called it as a 555 number it comes. 3 resistors, 5 kilo ohms series. 555, it is a 555 timer. They're telling that one. It can be jive the both transistor logic due to its high output current and CMOS logic circuits. Right. It has a high output current and adjustable duty cycle. Right. 555 timer can be operated in both astable and monostable. Right. These are the application of an IC 555 timers, astable and monostable. The output of 555 timer can be source or absorb the current up to 200 milliamperes, sinking or sourcing the current to the load. Sourcing the current to the load. It contains 24 transistors, 2 diodes and 17 resistors. 555 timer is available as a 8-pin dual inline package. 8-pin metal can be or 14-pin dual inline package. 8-pin in metal can used, 14-pin dual line packages it made by the semiconductor devices. Then the applications of the IC 555 timers. There are the many applications we are going to see in the 555 timers. In the day-to-day life also we can see that one. Like in your for example, in your home functions, they are using the lightings, blinking lights, on and off lights. They are using the IC 555 timers. Right. Let us see that some electronic devices where they are using. We can see that one. Then we can discuss about the day-to-day life. In the PWM, pulse width modulation, and PPM, pulse position modulations. Pulse width modulation and pulse position modulations they are using in the signal systems. DSP, digital signal processing they are using. Duty cycle of oscillators, lamp dimmer to provide the accurate time delays. As a flip-flop elements, digital logic probes. Probes means in your lab you are using for the CRO wire connecting, that is a probes. Analog frequency meters, quad timer applications, pulse waveforms and the square wave generations, stepped tone and tone burst generator and linear ramp generations, tachometers and the temperature measurements. It can be used as a monostable multivibrators and the astable multivibrators, DC to DC converters, DC voltage regulators. DC voltage regulators, your mobile battery charges. Voltage to frequency converter, frequency divider, Smith trigger, cable tester, pulse detector, wiper speed controller. In your cars, you have to control the speed of the wiper. Right? We can control the wiper speed controllers, timers, switch, and one more. It is in the burglar alarms. In your, for example, in the banks, the robber will attack on the banks. That time robber it stores the money from the bank. It starts alarming when he touch the locker. It starts alarming. In the toxic gas alarms, in the huge industries, any gases leakages there, when it sense the smell of that gas and then starts alarming. They're also using the IC 555 timer, right? These are the applications of the IC 555 timer. Let us see the pin configurations of the IC 555 timers. Right? The pin configuration of the IC 555 timer is: pin number 1 is a ground. Pin number 1 is a ground. Right? Then 2 is a trigger. Trigger means if you are whatever giving the input, if you give that one, it is in the high or a low, it decides. That is a trigger. 3 is a output pin. 4 is a reset. Set and reset. If it is a on state, it is a set. If it is a off state, reset. It decides this pin. It is in the pin number 4. Pin number 5 for the control voltage. An external voltage applied to this terminal, right, changes the threshold as well as the trigger voltage. This controls the triggered and threshold. Threshold voltage means it reaches the high voltage. If we are giving the 5 volt, it reaches the 5 volt, then afterwards the voltage will not pass that one, start discharging. The peak of the voltage, it is a high voltage, we can call it as a threshold voltage. 7 is a discharging. Charging and discharging, it is the working. Pin number 8 is a VCC. VCC is a power supply. That is a power supply of the plus VCC. This is the pin configuration of IC 555 timer. And then next we are going to study about the monostable multivibrators. This is the one of the application of the IC 555 timer also. Right. Let us see the monostable multivibrators. Mono means what? One. Single. Right. Stable means constant. Multivibrators means it doesn't forms the sine wave. Right. Here all the multivibrator circuits or depends on the capacitor charging and discharging. One thing. And one more thing is depends on the on and off state. On and off state of the circuit. That is a high or a low. Cut and clear answers you can get in the multivibrators. Right. This is the circuit diagram of the IC 555 timer of the monostable multivibrators. The same circuit will come for your practicals. Right? This is the circuit of the IC 555 timers of the monostable multivibrators. This is the block diagram of the monostable multivibrators. I am going to explain about the first one, components. This is a Q1 is a transistor. This is called it as a SR flip-flop. SR flip-flop, it is a new to you, but you can understand it in a simple way. I am going to explain about this one. In your PUC, you have studied about the truth table of the AND gate, OR gate. You have studied how it is come 0 0 1 1, 0 1 0 1. You have studied. The same way you have to study about the SR flip-flops truth table. That is the SR flip-flops truth table I'm going to explain about first. S and R. S is a set. R is a reset. Q is a output. Q bar is a reverse of the output. If you are giving 1 is a set, reset is 0, output is 1, inverse of that one is a 0. If the S is set is 0 and reset is 0, right, there is no change in the output, then set is 0, reset is 1, the flip-flop of the output is 0, Q bar is 1. If the set is 1 and reset is 1, output is 1 and the inverse is 0. This is the truth table of the SR flip-flops. And then I have already explained this as a comparator. Comparator, how does it works? If you are giving the inverting terminal to 9 volt, non-inverting terminal to 10 volt, you can get the minus VEE voltage. If you are giving the inverting terminal to 10 volt, non-inverting terminal to 9 volt, you can get the plus VCC. Plus VCC. This is the working of the comparator. Then these are the 3 resistors, 5 kilo ohm resistors they are using in the series. That's why it is called it as a IC555 timer. They have told that. 2 by 3 of VCC. 2 by 3 of VCC, it is in the voltage across this comparator. It is a 2 by 3 of the VCC. It is a constant till the end of the circuit. And 1 by 3 of VCC, it is in the output. Constant. 2:3 of the VCC here voltage we can get it. It is a 1 by 3 of VCC we can get it in this output. This is a power supply. It is a VCC, pin number 8. For example, it is a 9 volt they have given. 2 by 3 of VCC is 6 volt you can get it. In the 1 by 3 of VCC, 3 volt we can get it there. This is 1 by 3 of VCC, it is a discharging, and 2 by 3 of VCC, it is a charging. If starting of the circuit, Q1 is in the off state. Q1 it is in the off state. Q1 it is in the off state. Directly comes to here and it is trigger is here. The capacitor in the discharging state. It is in the low. If it is the transistor is on, if it comes to trigger here, it is starts charging. Are you getting my point? Clear. Then the transistor is on condition. Yes, transistor is in the on condition. What it is there? It is in the I'm going to tell that once again. Is Q1 is on, the capacitor is shorted to the ground. The transistor is in the on state. It is in the comes to trigger here. It is in the discharging state. It is in the off. If it is in the off state, it is in the charging. It is in the charging. If the Q1 is on and the capacitor C is shorted to ground, however, the application of the negative trigger pulse to pin number 2, it comes here, and transistor Q1 is turned off, which the release the short circuit across the external capacitor C and drives the output is high. That is the working condition of here. If the Q1 is in the Q bar is in the on, obviously it is in the 0. If it is the 0, S is 0, R is 1. If it is the 1, here the 9 volt, here the 10 volt. Here the 10 volt, here the 9 volt. Here the 9 volt, here the 10 volt. Right? It is in the transistor is in the on state. That time the trigger pulse is in the discharging. It is in the off state. Right? If transistor is in the off state, 0 state, the Q is 1, reset is 0, set is 1, this voltage is like that, then it is in the charging state. This is in the charging state and it is stable for few seconds. Then it is in the off state, it is in the off state. It is at present it is in the off state, stable. Then it is in the on state, start discharging. This is the circuit is working condition of the transistor. It is the threshold pin number 6, control pin is pin number 5 is here. 2/3 of VCC it is a charging and 1/3 of VCC it is in the discharging. Yes, this is a circuit is working condition is in the like that. Right. That is the monostable multivibrator. Let us see the graph of the multivibrators is output waveform of the monostable multivibrator is like that. The trigger is around discharging. I'm going to draw it. Then it maintains constant, stable. This is a trigger at pin number 2. This is the output. This is output. This is a capacitor charging, maintains constant, charging. This is the condition of the charging discharging curve of the capacitor. This is a capacitor circuit. Yes, this is in the pin number 5. This is a capacitor charging and discharging curve we can see in the pin number 5. Right, in the trigger we can see in the pin number 2. Output is what is the pin configuration of the output is pin number 3. This is a pin number 3, pin number 2, pin number 5. These are the graph of the monostable multivibrators. Right, these are the monostable multivibrators. How does this work? Next, come to the formula of the time during which the output remains in the high. Output remains in the high, that is in the TP. Output remains in the high. This is called it as a TP. How much it is in 1.1 of RA into C. Here you can see in this circuit, you can see that RA is here and C is here. This is the voltage of the TP is in the high of the, in this graph, this is a TP small t, this is a T, this is a voltage, and here to here it is a capital T. Capital T, it represents the time period of the circuit, right? Number of cycles per second, it is the complete one cycle. It is a time duration, that is a capital T, right? This is the voltage is starting with the 5 to 18 volts, we can take that one. And this charging and discharging curve, this is a charging and discharging curve. This is a charging, it is a 2 by 3 of VCC. Discharging, it is 1 by 3 of VCC. We are going to take that one, right? That is a working condition of the monostable multivibrators, right? This is the monostable multivibrators. How does this circuit works? We have to see that one, right? RA is in ohms and capacitors in farad, and TP equals to 1.1 RA into C. It is in seconds. It is in seconds. In the high state, until the set the time TP elapses, the output will not change its states even if an input trigger is applied again. During this time interval TP, however, the circuit can be reset during the timing cycle by applying a negative pulse to the reset terminal. The output will then remains in the low state until the trigger is again to applied. What are the applications of monostable multivibrators? We are going to see the graph of the monostable multivibrators. The output remains in the high for the time T out, capital T equals to 1.1 RC. That is the time taken for the capacitor C is charge, also known as the time constant RC. The capacitor voltage is exceeds 2 by 3 of VCC. The output from upper comparator to reset the flip-flop to 0, and the discharge the transistor Q2 gets again started providing the discharge part to the capacitor. As capacitor voltage comes back to 0 volts, the circuit come back to its normal state. Means upper comparator is reset to what? Reset The flip-flop is 0. Here the 0. Here the 1. When it is a 0, it is a 9 volt, it is a 10 volt. Right? That time what it comes? 0. And the discharge transistor Q2. Discharge transistor Q2, it is in the on state, gets again saturated, providing the discharge part to the capacitor. The Q2 is in the on state, the capacitor is discharging. As the capacitor voltage comes back to 0 volts, then the circuit comes to normal state. In the starting of the state, it is the output waveform is 0, then it is starts charging, then it is discharging, then it goes to the same waveform of the monostable multivibrators. This is a capital T, it is a small t TP, right? T equals to 1.1 into RA into C as per the first circuit, right? In your problems they can give that one, RA will give that one, TP will give that one. Calculate the capacitor value they may ask, otherwise capacitor resistance value will give, and TP they may ask, right? This is the based on that one they may ask for your examinations. Okay, thank you. Please watch the videos regularly.